All right, how's everybody doing out there in Math Magic Land? That's right, it's Mr. Muscarella coming at you. And in this video, we are going to take a look at describing location of a piece of data within a distribution. So let's go ahead and get those note sheets out and let's get ready to roll. Now we're going to take a look at two characters and from a classic 1985 movie, Back to the Future. And we're going to compare their scores relative to their peers, but we want to know, how did Marty do on his test? So let's take a look at the data we got to work with here. Now, we're doing this relative to his peers. So did he score better than his peers, worse than his peers? So we will take a look statistically and see what's going on here. Now, when we take a look at our test scores, so if we count the number of scores from 60 all the way to 99, we will get a value of 20. So there are 20 scores, so we're going to write down n equals 20. That's going to be an important piece of data that we'll need there. And the other two pieces of information that we're told is that the mean is 80 and that the standard deviation is 10. So more about on these terms later. And you should probably be familiar with the word mean already. That's just average. And standard deviation is what we'll be learning about shortly. Now, the two of the main characters in the movie, Back to the Future from 1985, was a gentleman by the name of Biff, and Biff was just a bully. He drove around town in his really cool car, really popular guy and everything, and he bullied actually Marty's dad and Marty as well, and then Marty, of course, was played by a very talented actor, Michael J. Fox, in this movie, and he drove around town in his really cool skateboard. So very different characters and everything, and so I highly recommend you watch that movie if you haven't already. It's classic. Now, Biff scored 60 on the quiz, and we want to know what percentage of the scores are less than 60. So the data, if you notice, is in order from 60 all the way up through 99. So if I take a look where Biff's score is 60. So if I were to look at that, that's right here on our number line at 60. How many are less than, what percentage of scores is less than 60? Well, we don't have anything less than 60. So that just means we would have a fraction of 0 over our 20 pieces of data. And when we calculate that, we would get 0.0, which is the same thing as 0%. So as a decimal, we don't have any, but we're asked for the percentage of scores that are less than 60. Now, Marty, on the other hand, he's a nerd, he's pretty smart, and he ended up getting a 90 on the quiz. So if I look at his, I've got 90 is where on the data set. So I've got to kind of check that out. And 90 is all, come back here. So 90 is all the way over here. Now, there's a couple different ways we can do that. Now, we want the percentage of scores less than 90. In Biff's case, we wanted the scores that are less than 60. So when we're finding this value of one score that is less than a certain other value, we're going to talk about the word percentile shortly, but that's what we're finding. We're finding what percentile our score is in. Now, for Marty, if I look at 90, there's two ways to calculate this. One, the easier way, because it's kind of towards the right side of the data, I would just say from 90 up, I have 4 pieces of data, because I can count from 90, 93, 97, 99. But the question is asking us for how many are less, what percentage of scores are less than 90. So if I have 20 pieces of data, 4 are at 90 or higher, that means that there's 16 pieces of data that are lower than 90. Now, I could have also just counted each one individually, 60, 65, 65, 60, 75, 75, etc., all the way up to 87, and I would still arrive at 16. Either way, we're going to calculate that percentage, so we would write our fraction 16 out of 20, which if we reduce that, we get 4 out of 5, which is 0.80 or 80%. So 80% of the scores are less than 90. So this is going to be the idea of a percentile, and we'll talk a little bit more about that later because this is just an introduction. Now, the other two ways that we'll describe a score, so one way is in the percentile, another way is how far away the score is and what direction from the mean, and then we'll talk about how many standard deviations away a score is from the mean. So first, if we take a look at Biff's score of 60, this is going to be one of the things we'll do. So Biff's score, so whatever his score is, minus how far away is it from the mean. So this is going to be kind of the formula that we'll use to do this. And it's kind of common sense too, because he's got a score of 60 and the mean was, we were told, was 80. So if we subtract those two values, we'll get a value of negative 20. Now to describe how far away it is from and in what direction, because we have a negative number when we did that calculation of score minus mean, we would say his score is 20. And in the direction, because we're less than the mean, we would say that it is 20 below. So Biff's score is 20 below the mean. Now we're going to use that value when we talk about standard deviations. And now his score of 60, how far away from the mean is that? Now we're told that we've got a standard deviation of 10. And a standard deviation of 10, we're going to use that value with the number that we just came up with from Biff's score being above or below the mean. We're going to use those two values to calculate the standard deviation, how far away he is from the mean. So to do that, we're going to first take that value, how far away, which was the answer we just got. So how far away, and we're going to divide that by, in standard deviation, I'm just going to abbreviate SD. So Biff's score was negative 20, and the standard deviation we're told is 10, which means if we do that calculation, we reduce that, we're just going to end up with negative 2, and that's going to give us a z-score of negative 2. So we're going to talk about z-scores shortly and get into those a little bit, but just an introduction on how to calculate those values for now. Now, how far from the mean is Marty's score of 90 and in what direction? Now, so we have Marty, he got a score of 90. So, wow, Marty, he gets a 90. And then the mean, of course, was 80. And so when you subtract those two values, you're going to end up with 10. So it makes sense, you know, if the mean's 80, his score is 10 higher. So we would say Marty's score is 10 above. So the words above and below are going to be used to describe the direction, and then the value that you come up with will always be positive. So you want to kind of think about it like absolute value. It's how far above or below a certain number is. So in absolute value, it was how far a number was from 0 on a number line. All right. Now when we take a look at Marty's standard deviations, he was 10 above. So we're just going to use that number 10. That's going to go in the top. And then the standard deviations, that value was given to us. That's just 10. And when we reduce those two, we are going to get a value of 1. So his z-score is going to be just 1. So he's going to be 1 unit away from the center and everything. Now, I want you to go ahead and hit pause and try number 4 completely on your own. And then come back and check yourself to make sure you didn't wreck yourself and that you're good on this. So go ahead and hit pause and then come back and let's see how you did. All right, Cub Scouts, how did we do? Hopefully, you came up with a value of 17 above, and you came up with a z-score of 1.7. Now, when you show your work for this, so if this were class, you know, and we were doing this on a quiz, you know, I always want you to show your calculations that you use to come up with how far away a score is. And then when you describe it, you're going to make sure that the value you use is positive, and then you're going to include the word above or below. Now, when we're calculating standard deviations, again, show your fraction for that, and then do your calculation appropriately with that to identify what the z-score is. And you could actually put z in front of it because that's actually what we're calculating. So as long as you identify z being 1.7, but show the calculations and the work that lead to your solutions. We don't want any what are called bald answers where it's like, yeah, here's a number, just came out of nowhere. Now, question number 5 is we're going to have to think a little bit about this. So we have a student by the name of Lorraine. She scored 1.4 standard deviations above the mean on her first bio test, and she got a 1.9 standard deviations above the mean on her first psych test. Was her test score higher for bio or psych? Well, we can't really tell. So we have no idea. So we can't tell, and here's why. In order to figure out the score, like how her actual test score was for bio or psych, we've got to know 2 things, and here's what we don't know. We don't know the mean, and we don't know the standard deviation. So we need to know those 2 things in order to tell whether her actual test score was higher in bio or psych. Now, what we do know, we were told like her standard deviation for her bio test was 1.4, and her psych test was standard deviation 1.9 higher. So we can clearly see 1.9 is greater than 1.4. And with that, that's our psych test is higher compared to her peers. So her psych test is greater, is a little bit better relative to her peers. So that's going to be an important thing, because when we talk about this, we're only talking about everything else in the data set. And the data set in this case, of course, would be her classmates. So her psych test is better relative to her peers, but we can't tell what her actual value was. What score did she get on that test? All right, so that's it for this guy. All right, so let's go ahead and summarize our lesson here. And first thing that we're going to take a look at is going to be the percentile. And to calculate the percentile, we're just going to determine the number of data below a given value and divide that by the total number of data, changing that to a percent. Now, the other two pieces that we'll work with are going to be about the z-score. And to calculate a z-score, we'll take whatever given value we are looking at, subtract the mean from that. So we'll find that difference, and the order does matter. So be very careful with that. And we'll divide that by the standard deviation. And the number of standard deviations, we'll describe that as being above or below the mean. So there's going to be two parts to that component. And then we're using z-scores to describe, to compare values from different distributions. Like one distribution might be SATs, another might be ACTs, or like we just saw in the previous example, test scores from two different classes, psych and bio. So we're going to have different distributions, but we've got to compare them somehow. And a z-score is just a unit of measure. And very similarly to units of measure for distance, we could have feet or inches, miles, kilometers, centimeters, millimeters. So those are all units of measure for length or distance. And like Celsius and Fahrenheit are units of measure for temperature. And so is Kelvin. So those are, a z-score is just a unit of measure. More on this stuff later on. So what we're going to take a look at next is going to be looking to see how fair voting is in the U.S. House of Representatives, because it has 435 voting members. Unlike the Senate, which gets 2 members per state, regardless of how big or small your state is, the U.S. House of Representatives has 435 voting members, and that is because of based on population. So the bigger your state, the more you will get, the more representatives you'll have, and the smaller the state, you won't have as many voting members in the U.S. House of Representatives. So we'll take a look at that and compare that. Now, that was passed in a law in 1929, and it was set in Congress in 1913, but a law made it 435 people in the U.S. House of Representatives. And just as a fun fact, that is not written in the Constitution. It's not a constitutional provision. So you could change that number of people in the House of Representatives, and there's all these different theories on it. One of them is called the Wyoming rule. Another idea is called the cube root rule. So in order to make the voting more fair, those are a couple ideas that different people have kicked around over the years. So more on that later as we take a look and get into the U.S. House of Representatives and the fairness of the state of Ohio with its representation. You guys make it a great day as always, and I'll catch up with you later. Peace out.